All right, let's get better here at this first problem. So when we need to complete the square, we want to line up our x terms, and we know we're going to add something. So we set it up like so. And then we have plus y squared. And then we're going to bring over this minus 8y term plus something. And then we know that we got to get this 16 to the other side by subtracting it to both sides. So we got negative 16 there. Okay, so looking here, if you take half of 6, that's 3. And then 3 squared, you put in 9. Half of 8, 4. 4 squared is 16. But I got those so that I have a perfect square trinomial right here and a perfect square trinomial right there. But right now, when we look at this, I really added 9 and 16. I really added 25 to one side. That's cheating unless I do it to the other side. So now I got 25 there. So here, if we factor this trinomial, you will get x minus 3 times x minus 3, or x minus 3 quantity squared. And then factoring this one will be y minus 4 quantity squared. And then obviously we're getting just a 9 right there. So out of this problem, this is the standard form. Look back at your notes on that. That puts our center at HK, which would be 3, 4. So if I go on graph, 1, 2, 3, 1, 2, 3, 4, there's the center of my circle. The radius is this number by taking the square root of that number. So we're going to get 3. So we'll do our best to sketch that. And then here we are. You could sketch this one out big time, but what you really want to know, what you really want to do when you read this is see that the endpoints of a diameter are given to you. So basically, if you have a circle, and this will not be to scale, I just want to show you here, and then we have, the endpoints of a diameter, we know that the center is going to be the midpoint. So basically, if you take the average of these two values, you got 5 and negative 3. So 5 plus negative 3 and divide that by 2. What are you going to get? And then you take the same thing with the y. 6 plus 4, divide that by 2. So it's the average of those endpoint values. So I got positive 2 over 2. So my center is going to be at 1 and 5. Okay, so this point right here is 1, 5. So I know a lot from that. If that's my center, then I know that's my h and that's my k. And then literally the final answer to this problem is x minus 1 quantity squared plus y minus k quantity squared equals, and then I just need the radius squared. So there's a couple ways of doing that. You could do the distance between these 2 points. I personally will like to just use what I just found, 1, 5, and either of those points there. So if I call this x1, y1, and this x2, y2, and I find the distance formula here, I am literally finding the length of the radius. So x2 minus x1 will be 1 minus 5, positive 1, sorry about that, and then plus 5 minus 6, quantity squared. So I'm getting here negative 4 squared is 16, plus negative 1 squared is 1. I'm getting the square root of 17, but don't forget that means that's my radius. So if I square it, if I take this and square it, looks like that's the end of this one. Enjoy your last number flare, because there we are. All right, so there's the final answer to that one. All right, hopefully you read that problem a few times and understand kind of what's going on here. So let's draw the Ferris wheel, first of all, okay? So what do we know about this Ferris wheel? They do talk about the center being on the y-axis after you read it a couple of times. So if you know that this has to be on the y-axis here, all right, and y representing the height above the ground, reading this problem a few times, you'll see that this point up here would have to be 243. Now, how do I get that? Because it's 243 feet off the ground. All right. Well, since the diameter is 230, we got a radius of 115 and a radius of 115. That's a grand total of 230. So we know right now that this is not going to be, this origin here is not going to be right here. And in fact, if you take the 243 minus the 230, you're going to get a 13 here. All right, so what does this mean? Well, basically we're just setting up the problem here and trying to find out what this value is here for the center of the Ferris wheel. Well, if you have the 115 plus the 13, that's going to give you the 128. So a lot of your problem right here you have x minus 0 quantity squared plus y minus the 128 quantity squared equals, and then you don't have to do any calculating here because we're basically given our radius. So we have 115 squared there. All right, honestly, we'll accept that answer. If you want to clean it up a little bit, we get x squared plus y minus 128 quantity squared equals, and then that's 13,225. All right, but either of those honestly would work for that problem. I always like to sketch a little diagram of what's going on with these. So when you read this, write the equation of a parabola with a vertex at 4, 3. All right. So 1, 2, 3, 4. 1, 2, 3. All right. So far, all I know is that's my vertex. But then when I'm given a directrix that goes through 10, 3. All right. So now I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 3. Here. Okay, it goes through there. Well, a vertex and a directrix, it's not the axis of symmetry here, okay? So once you know the vertex and the directrix are on the same horizontal line, a point on it, that is, that point given, we know it's going to have to look like that. So once it looks like that, we understand, what is the relationship between, any parabola. So we have a parabola, and this is where this really comes into play. I have a vertex, I have a focus, and then I have a directrix, right? And this distance is identical to that distance. So that's how we come up with our relationship here. So I want to write the equation of this parabola. Well, I'm just going to tell you right now, it's gonna go like this, right? I mean, we know it's going to be like that. So we are in the form of x equals a times y minus k quantity squared plus h. Okay, so that's that. Whoops, sorry, it's a little off screen there. But that is the general, vertex form for that horizontal parabola. All right, so what do we need? Well, just know that right away we can fill out, the y minus what? Well, the vertex here is at 4, 3. So using our new method, and this takes a little time to get the hang of it, how that works, but we have our h value here and our k value right there. Okay, so I need x equals, and I need that a value. So instead of mathematically calculating it out, just know that relationship is a equals 1 over 4p. Well, if we look here, the distance between here and here, that p value is 6 if you count that out, because it goes from the 4 to the 10. So if I know that's what's happening, I know that 1 over 4 times 6 is happening. So my a value is 1 over 24. Now, some of you got it all the way right to there. Just remember, which way is it facing? It's facing to the left. So what we got to do is just put in a negative there. And that is how we come up with that, knowing our relationships of parabola. All right, on this quiz, we were able to see a difference between standard form and vertex form. This is standard form here. So like we typically do, we want to start with opposite of b over 2a on this one, but this time it starts with the y. So y equals the opposite of b, which is 4 over 2 times a, which is just 2. So we get y equals -2. Now remember, that is our axis of symmetry here. So we can go ahead and we can sketch that in right off the bat. And we got y equals -2. To find the vertex, we're going to take that and plug it in. So x equals the opposite of 2 squared plus 4 times -2. Tack on the 3. Very procedural with these once you get the hang of them. So we got 4 minus 8 plus 3. My x value here is -4 plus 1 or -1. So be very careful. I got a lot of these switched around. This is the x value, so that's a -1, and the y value is -2. So it is on this line, -1, -2. There's our vertex. All right, so what do we do now? Actually, pretty straightforward. There's a positive a value up here, and the a value is 1. So all we got to do is do what we would normally do for a vertical parabola. There's no nothing crazy, and it opens up to the right. So normally up 1, we're going to be over 1, up 2, 1, 2, 3, 4. 3 is going to be 5, 6, 7, 8, 9. And as we know, these are symmetric. So we sketch this one that way. Oh, now we look at our domain. The furthest this goes left is -1, and there is a value of -1 there, and then it goes to positive infinity. We got ourselves vertex form here, and it's actually normal in the sense that it opens upwards. It's a function, so our vertex is going to be at -2, 4. When we look at that over here, 1, 2, 1, 2, 3, 4, we know that it's either going to go upwards or downwards. Oh, it's facing down. Got it. So we are actually going to have an axis of symmetry here, which is not asked for exactly. But this is the key. The key here is just, once again, this is our A value. So knowing that relationship connecting these A values and P values is this right here is absolutely essential. So A is equal to 1 over 4P. So that means 1/8 is equal to 1 over 4P. Well, if you just look at this right here, you could cross multiply all that. You're going to get P value of 2. Remember the negative, the reason I didn't put the negative in here, that just tells you direction, that it's opening downwards. P is a distance, okay? So once again, remembering, very important that whenever we have this, I'll just show this on here, this is, remember, the vertex of the parabola, okay? Since we now know it opens downwards, if we go 1, 2 this way, that P value of 2, that's where that directrix is gonna be, okay? How do I know to put it there? Because it's opening downwards and the directrix is in the outside of the parabola. If we go down to there, right there at that X, that's the focal point. All right, so I can fill out the focus right here as -2, 2. And the directrix up here is a horizontal line, so instead of up 4, we're up 6. So that's y equals 6. Now, what is the latus rectum? Well, that's actually how I'm going to graph this one instead of using the A value, which I could. All right, but I know that the latus rectum has a length of 4P. So if I go like 1, 2, that's my distance of P, and then 1, 2 again, that's going to be one of the endpoints of the latus rectum. So this is a length of 4, and then 1, 2, 3, 4. How did I get that 4? Because P equals 2. And once again, that relationship between, just kind of show this here. If I have a focus, this is P, and then from here to here is 2P, and from here to here is 2P. So I know that this distance has to be 4P, and since my P value was 2, it's going to be a length of 8. And that's good enough. Those 3 points for this type of graphing is completely fine. Just kind of sketch your graph. I know it won't be necessarily perfect on your other key points, but just so we are aware, let me use a different color here. This is the latus rectum by definition, okay? So they're asking me what are the endpoints. One of them is -6, 2, and then the other one over here is at 2. All right, when you're doing these problems, you want to put a nice convenient spot as your origin. Put your vertex at the origin if you can, and you can on this one. So if you look at this problem, first thing we want to do is come up with the A value using the fact that we know this is vertex form. And the reason this works out really well is our H and our K are both zeros on this problem. So we do have an ordered pair known on this graph. So it's like a 2-step procedure. We know we're going over, not 600, but 300. And then we're going up 80. So there's a point, 1, 2, 3, 4 unknowns. 4 known values. And there's an equation here with 5 unknowns. So we're going to look for the A first. So this is the Y value right here. So we got ourselves 80 equals don't know A. Here's our X value of 300. And then plug in your vertex, which is very nice at 0, 0. So basically it comes down to 80 equals whatever 300 squared is, all right? 300 squared. If you divide both sides by 300 squared, which is 90,000, okay? And then you simplify that, you actually will get 1 over 1125. There is your A value. Now, how does that help us? Okay, well, that means right now that the equation of this parabola, if we were to make this parabola and make an equation, we have y equals 1125 x squared. Because remember, the vertex is at 0, 0. Makes it very nice. Well, this problem, it's, you can read it through, hard to see this question mark here, but it's essentially asking for a y value here. So it's like, hey, I got 150 here. What is that value right there? We'll just make that your y value that you don't know. And you do 1 over 1125 times 150 squared. And when you crank all of that out, it comes out exactly to 20 feet as an answer.